Okay, so tonight guys I wanted to just do a kind of an introduction video into the electronic throttle control system on the SX4. And so here's just a simplified drawing of the system. So we have the engine control module, we have the electronic throttle body itself, let's call it, including the motor, a gear train here in order to drive the butterfly in the throttle or the throttle proper, and of course the torque demand comes from the accelerator pedal position sensor. So depending on prevailing conditions, let's call it, in the car, keep in mind guys that you can also have a traction control intervention, ABS or electronic stability program, ESP, intervene in order to control the throttle as well in the car, but that's a discussion for another day. Let's just keep it simple. So as you step on the pedal, assuming you have no fault with the system, the relay will be closed here, allowing power to go to the H-bridge, which is essentially the driver transistors that will then pulse width modulate either side of the motor. That is to say, an H-bridge. This H-bridge control here, can you see this here guys? So anytime you see an H-bridge type driver circuit, basically you have a motor which is bidirectional, so that can control not only the direction of the throttle, but also the rate of travel of the throttle. Again, there's the relay, so that's the throttle body proper. The electronic throttle actuator, let's say. Over on this side of the drawing is the APP, the accelerator pedal position. There's 2-channel, as you can see, and the throttle position is also 2-channel feedback to the system to monitor for any faults. Obviously a safety critical item, right? So that's all I'm going to say about the control for now, right? Essentially we have a pedal monitoring torque demand, electronic control module itself, the brains of the car, driving through the H-bridge here, driver circuit, driving the throttle actuator either open or closed depending on the torque demand, and if a fault intervenes, there's also fault monitoring facility here that it can actually pull the power from the throttle entirely and it goes to a default position. Okay, so I think some people get a bit confused when it comes to throttle control actuators, guys, because they're really torque motors of sorts. It's a servo motor, yes, because the function is going to be affected by the feedback, but it's really generating a torque either to open the plate or close the plate, and again either with or against the bias spring in the system. The amount of torque that's required, not the travel, is pulse width will affect how much torque is being applied to the motor. Not necessarily movement, it could be stationary, but if it's working against the bias spring, you're going to need some torque to keep it in a fixed position. I hope that's clear. So at the connector, at the accelerator, the electronic throttle control actuator itself, 6 pins on the connector here guys. Let me actually show you where I'm pinned in. I'm pinned into the blue and yellow, and the white, again, just the single feedback position feedback line, just to keep it simple. Let me show you on the car, and here's what it actually looks like. Again, here's the yellow for open. You can see I had to swap the lines. Well, the pins are, you can see, it's green and red, goes to green, red, green and red. So this is the open side of the coil, close, pulsed of course, depending on the rate and direction, these two, and this is just our relative position feedback. And the higher the DC voltage on this line, the more open the throttle actually is. This kind of made sense color coding wise to me, that we can see the opening pulses on the green for go, red for, yeah, you guessed it, stop, for closing the butterfly in the actuator itself. So I'll only have the single channel on here because I don't want to confuse the issue with respect to feedback. So essentially the higher the voltage on the channel 1 here, so it's channel 1, 2 and 3 respectively. Channel 1, this is from the throttle body position feedback circuit. So the higher the DC voltage, the more open the throttle actually is, right? So let me just go on inside. I'll take you inside the car. We'll turn the key. The presence of the pulse will depend on direction, of course, but the width of the pulse will depend on rate of commands. Just take a look at that. Go on and turn the key. So just in the car here, guys, I'll put the flash on so you can see what I'm actually doing. So of course the APP is at the base of the gas pedal. It's actually an air pedal, I suppose, if you think about it. But so I'll just turn the car on here. So the throttle, first few seconds, the throttle will actually open, go to its default memorized positions, and then what I'm going to do is just slowly depress the pedal entirely, and then quickly release it. The reason for that is I want to show you how the rate of change actually changes the pulses. Initially, let's just zoom out completely here and we'll see the whole capture. Okay, so again, what we have here, guys, is the pulses for opening the throttle and the pulses for closing the throttle. And again, the relative position, the higher the DC voltage on the yellow trace, channel 1, the more open the throttle actually is. So this is idle, and this is wide open throttle. I think you can see the claim as I'm stepping on the pedal there. So when the system first becomes active, you can see that it's actually being pulsed in order to keep the throttle in the relatively closed position, in its default idle position that's actually memorized. That's of course captured in the ECM from the state of the engine, basically. So that is kind of a target idle position that the system's trying to keep it in. And as a step on the pedal here, we're pulsing the system positive, if you will, to open the throttle, or in that direction of the coil. So opens the throttle, and then when I lift, you can see the trace drop drastically here because I slowly opened it and drastically closed it. So you can see again we're closing it, and again it opens it a wee touch in order to go back to its default idle position. So let's look at this a wee bit closer. A lot closer. So here's where the system first becomes active. Again, the pulses keeping it in a relatively closed position. Here's where I first step on the pedal. You can see the trace going positive there with respect to the throttle position. There's no closure signal, of course, because I'm increasing the throttle. Can you see the width of the pulses here? Can you see how wide they are? Again, just stepping through it. Here's where I lift that's where I lift completely and just let the spring pressure on the APP actually drive it back to the its neutral, its undepressed position, let's say. Can you see how wide they are right here? It drops a wee bit below its target position there. A little pulsing to get it back to target. Just a final note here, guys. It should be appreciated that because this is a safety critical item, if there is a failure in the monitoring or in the control circuit at all, it will pull the power from the system, and the throttle will actually default to I think it's 7 degrees from closed position. So you'll have effectively a part power position. Whether you could start the car like that, I don't know, but the car will continue to run in a low power mode, let's call it, right? Let me demonstrate that to you now. So we won't have any drive in order to control the actuator, open or close. There's springs inside the assembly and the gear train, and it will default to this position. I believe that's how it worked. The detail in the manual is a wee bit scant, but I believe that's the case. Let's see what happens. So I actually think this goes some way to explaining why there's drive in idle here in the closed position. It's because the spring will default the throttle open even further than the desired idle. Let me show you. So look at the relative position. There's the throttle position trace. Again, we have no drive in the open direction, and when I pull the this is the fuse that supplies the power to the drive circuit, the H-bridge. There goes the drive. I have no drive, and the relative throttle position actually opened a wee bit there. You can see it. You can hear the car obviously hunting. Not ideal, but better than dead in the water, I guess. Okay, so I didn't want to make this too difficult to too deep here tonight, guys. I just wanted to make it simple for the introduction, if you will. We'll get into more detail. We'll get any more detail as we go along, because it's kind of a lot to take in a single video, I think. Well, not for some, of course, but these videos are really geared towards the guys who are new to this. So again, electronic throttle control, guys. Just an introduction. That's it, boys. Cheers.